Hey grade 6, a new video for you guys today. We're going to focus on something called prime numbers and composite numbers. Actually, this video is going to be split into two parts, one for today and probably one for tomorrow. We're going to first focus on prime numbers and composite numbers in the first part of this video, and then part 2 is going to focus more on something called prime factorization, and we'll get to that in a little bit. Here's where we're going to start. This is our title slide, and so it's got some learning targets for you guys to look at and focus on. And so the learning targets, there are two of them. The first one is to determine whether a given whole number in the range of 1 to 100 is prime or composite, and recognize that any whole number is a multiple of each of its factors. Now, there may be some words in that sentence that you're maybe a little bit confused about, but we're going to go over the definitions and talk about what those mean as we go through the first number of slides in the slideshow. The second learning target, and that's going to do more for the next video for this one, is to draw factor trees and find something called prime factorization of whole numbers. And again, there might be some words in that sentence that are a bit unclear, but as we go through these videos, they will become more clear. So here's where we're going to start. We're first going to just look at remembering whether or not numbers are factors of other numbers. And so if we look at the number 2, the question is 2 a factor of 13? So what we want to think about is there any multiplication question where 2 times something equals 13? And the answer to that is a resounding no. Nothing times 2 is going to be equal to 13, okay? The next part of the question is what numbers is 1 a factor of? That's not a trick question, it's an actual question, but the answer to that is every number. 1 is a factor of every number. Okay, just a bit of good information to know. What numbers are factors of themselves? Which is maybe a strange way to word it, but so for example, if we end up writing out the factors of, let's say, 6, we'd say that 1, 2, 3, and then 6 is a factor of 6, because each number will fit into itself once, right? And if we think about factor pairs, 6 pairs up with 1. In other words, 6 fits into itself one time. So every number is a factor of itself, okay? Now, the next part is to just focus on how some numbers have lots of factors and other numbers have only a few. And so trying to think here for a quick sec, is 5 a factor of 20? Yes, 5 is a factor of 20. We can say, 20 divided by 5 equals 4. So we could also say like 5 times 4 is 20. Nope, that's not the right number. Five times 4 equals 20. Then the next question is 5 a factor of 21? Well, no, we just demonstrated that 5 is a factor of 20, and so we can't multiply 5 times a number to get 20, or we can't multiply it times a whole number to get 21, put it that way. Okay, so we've used division to prove that 5 is a factor of 20. We found out that it fits into 24 times, and then that means that we can move on. So the next question here is to figure out which number has more factors, 9 or 10. Okay, and so we can start writing out the factors of 9 and say, well, I know that 1 goes in, 3 is a factor, and then 9 as well is a factor, and that's it. Those are all the factors of 9. If I want to write out the factors of 10, right, 1 goes in, 2 goes in, 5 goes in, and 10 goes in. And then I'm going to just use little commas. So 10 in this case has more factors. The large number has more factors. Now, that may not be the case over here. If I have 12, 12 has 1, 2, 3, 4, 6, and 12. Those are all the factors of 12. And so for 13, there are actually only 2 factors, 1 and the number itself. And those are all the factors of 13. Now, because 13 only has 2 factors, that makes it a special kind of number, which we'll talk about in just a second, but I bet you can probably figure out which one it is. If you want to figure these ones out on your own. You can pause the video and work on those yourself. So just give it a pause for a sec, try them out, and then I'll tell you in just a second which one's got more factors. So 24 actually has more factors. It's like 1, 2, 3, 4, 6, 8, 12, and 24, whereas 25 only has 1, 5, and 25. 35 or 36. 36 actually has more factors. It's like 1, 2, 3, 4, 6, 9, 12, 18, and 36. And then for 45 or 46, it is, I might have to write them out. I believe it's 45 has more factors, but I could be wrong. And if I am, I'll put a note on YouTube. Okay, so sometimes the greater number has more factors. Sometimes the lesser number has more factors. Now, mathematicians have divided whole numbers greater than 1 into two main categories, right? One of them is called prime numbers, and the other one is called composite numbers. And so prime numbers have only two factors. They've only got 1 and the number itself. Composite numbers have more than two factors. So if a number's got 3 factors, that means it's a composite number. And so what we see here, these are all of the prime and composite numbers, looks like up to 19, right? So we see that 2, 3, 5, 7, 11, 13, 17, and 19 are all prime numbers, and then these ones are all composite numbers. One of the things you might notice is that there's a lot of even numbers on this list, because we know the divisibility rule for 2, which probably tells us why there's so many even numbers on here. So it says to find the factors of the numbers from 2 to 19 to see if you can determine the rule. What makes a number prime and what makes a number composite. Again, composite numbers are any numbers that have more than 2 factors. So the number 20, you probably know right off the top that 20 is going to be a composite number. 21 is a composite number. 22 is going to be a composite number. And 23 is actually going to fit over here because it's a prime number. Okay, so yep. Let's move it on. What makes a number prime? Well, it's having only 2 factors. Which also means that like the number 2 itself is interesting because 2, even though it's an even number, is technically a prime number because it's only got 1 and 2 itself as factors. Numbers that are composite, having more than two factors. That's really simple definitions. Now the number 1 is actually an interesting case, which I'll talk about in a second. It says that if there are any factors between 1 and the number, then the number is composite. If not, the number is prime. So looking at these, we're going to say, first of all the even numbers, they're composite numbers. That's just easy. 21 is a composite number because it's got a factor pair of 3 and 7. 23 is actually a prime number. 25 is a composite number, 5 times 5. 27 is a composite number because you have 3 times 9. And 29 is actually a prime number because it's only got 1 and 29. So this, I just alluded to this a second ago, but how many factors does 1 have? Interestingly enough, 1 only has 1 factor, and it's the number 1. So we then say that 1 is neither prime nor composite. I can't actually remember if there is a classification for 1, but it's not a prime number, it's not a composite number. It's just the number 1. Okay, so then we move on to the next thing here where it says a whole number is a multiple of each of its factors. From knowing that 2 times 3 equals 6, we can say a couple things. First of all, that 2 is a factor of 6, which means 2 goes into 6 evenly, right? And we can also say that 6 is a multiple of 2. Now this is a question that's in your workbook that just helps us remember the difference between factors and multiples. Someone told me once that one of the ways you can remember one of the differences between factors and multiples is that there are few factors and there are many multiples. So a bit of alliteration going on, but there are many multiples. In other words, if we're generating multiples of 2, you just start skip counting, right? So 2, 4, 6, 8, 10, 12, 14, 16, and you can go on literally forever. But the numbers, if we're trying to figure out factors of 6, there are only 4 numbers. There are few numbers that fit into 6 evenly. So, a bit of practice with that real quick. And again, if you want, you can pause and try these on your own and then get into the practice in your workbook. But I'll just do them after you pause. So we say that 4 is a multiple of 2, but 4 is a factor of 8. 3 is a multiple of 1, but 1 is a factor of 3. We say that 40 is a multiple of 8, but 8 is a factor of 40. Sorry that my face got in the way of that question, but so remember, few factors, many multiples. So, just one thing to remember, all even numbers are multiples of 2. So what does that mean? That means that if all even numbers are multiples of 2, that means that all even numbers greater than 2 are composite numbers. All right, so some factor pairs with 2 to make the number. We can say here that this is 2 times 6. This would be 2 times 7. This would be 2 times 15. This would be, 2 times 24. And then this one, this is a bit of a bigger one, a bit more of a challenge, but I can say that this is 2 times 43,212. You can just cut each of these numbers in half. All right, so are these numbers prime or composite? So we have the number 12, the number 30, 48, and 86,424. These are all even numbers. They all end in a 2, 4, 6, 8, or 0. So then they're all composite numbers because they've all got 2 as a factor. It says, are there any even numbers that are prime? How do you know? Well, we talked a second ago that there is. The number 2 is a prime number because it's only got 1 and itself as factors, and so it follows the technical definition for a prime number. So that is all for this lesson. This is, like I said, the first part, and so my next video is going to focus on something called prime factorization, and I will just get that going. So thanks for watching, and have a great day, you guys.